Good morning, everybody. Today I will discuss multiple and partial correlation. Correlation. The relation between two variables is called correlation. For example, the relation between price and demand and supply, and also pressure and volume, speed and time. These are called the correlations of examples. Now, the introduction of correlation. When the values of one variable are associated with influenced by other variable. For example, if price and demand of the goods, height and weight of the persons, these two examples between two variables are two factors on the values of one variable may be influenced by other variables. For example, the yield of crop per acre, say x1, will depends upon quality of seeds x2, fertility of soil x3, fertilizers used x4, irrigation facilities x5, weather conditions x6, and so on. When we are interested in studying the joint effect of group of variables depends upon a various not included in that group, then further studies is called multiple correlation. Definition of multiple correlation: the degree of relationship existing between three or more variables is called multiple correlation. Now, using the Eule's notations, let us consider a distribution inducing introducing three variables x1, x2 and x3. Then the equation of the plane of regression x1 on x2 and x3 is given by it, or x2 and x3 depends upon x1. x1 is equal to a plus b12.3 x2 plus b13.2 x3, that is equation number 1. Now we can assume that the variables x1, x2 and x3 have been measured from their respective means. Therefore, expectation of x1 is equal to expectation of x2 is equal to expectation of x3 is equal to 0, that is equation number 2. Thus, and taking expectations of equation 1, we get expectation of x1 is equal to expectation into bracket a1 plus b12.3 x2 plus a13.2 x3. Since x1 is equal to 0, that is why LHS side 0 is equal to, take expectation inside, expectation of a plus b12.3 into expectation of x2 plus b13.2 into expectation of x3. Since expectation of x2 is equal to expectation of x3 is equal to 0, that is why a is equal to 0. Thus, the plane of regression equation x1 on x2 and x3 becomes x1 is equal to b12.3 x2 plus b13.2 x3, that is equation number 3. Since a is equal to 0, already proved previous steps. The coefficient of b12.3 and b13.2 are known as partial regression coefficient of x1 on x2 and x3 respectively. Therefore, E12.3 is equal to B12.3 x2 plus B13.2 x3 is called the estimate of x1 is given by the plane of regression equation of equation 3, and the quantity is called the error estimate or residuals. In general case of n variables x1, x2, so on xn, then the plane of regression of x1 on x2, x3, so on xn, it becomes x1 is equal to b12.3 x2 plus b13.2 x3 plus and so on plus b1n 0.23 so on n minus 1 into xn. Therefore, the error of estimate or residuals is given by x1.23 so on n equal to x1 minus bracket b12.34 so on n into x2 plus b13.24 so on n into x3 plus b1n.23 so on n minus 1 into xn, that is equation number 4. The notations used here are due to event the subscripts before the dot is called primary subscribes and after the dot is called secondary subscribes. Thank you.